Alright, we're back. Convenient cut there for editing. I don't edit my videos. I just turn it on and off. Okay, we're missing a gear already. Okay, next problem. Cam cover right here. Okay, we gotta look at our bushing equipment. First you look at the bushing and see how smooth it is on the inside. They appear to be halfway decent. We have a brand new shaft sitting right here. And a nice brand new cover to go with it. Or at least it was new at one time. So take parts and merge them together and see what kind of fit you got. So when it moves like that, that's not exactly a tight fit. Obviously, crank alignment could be off of a little bit and not matter because you got a lot of clearance on that. So you got 2 or 3 thou clearance on that. It's not really worth fixing it. Shut up. Shaft's pretty smooth. My thumbnail doesn't dig in. That's good. Alright, so it's a little loose, but it's usable. It just cuts more oil pressure down that we don't have, so it'll be fine. Okay, here's the cam that was in there. Or it's going into there. Let's see, this looks like a brand new Andrews. Probably a stock replacement, I would guess. Don't know. There's a number right there if you can read it. Can't read it. Doesn't matter. Ooh, here's some numbers over here. S. S is for shit. That's what S is for. That's stock. So that's a low performance cam. Okay, so you put that in there. Drop it in the hole. Lift up off the surface just slightly. See how much rock you get. It's about the same as everything else loose. Okay, then you let it go all the way down. Now we're going to push it side to side as you're pushing down. If you have any click and derrick or noise, that means it's really loose. You check this way and side to side because the bushing can be that around. So I'm not getting any clearance this way. So that means the bushing can be barrel shaped, but right in the middle is tight because I'm not getting the clearance back and forth. Do it again. Getting nothing, so that's going to be good. We're going to say that's good. So make sure you make sure this is good and tight. Make sure this is in there also, the breather stuff. Make sure that it's cleaned out inside in there. This one had a lot of crap in there. And that hole goes down through here inside the cover all the way over to here and it blows out right in that chamber. And make sure all of that stuff is cleared out from the debris. If you don't clear that area out in there, you will have a bad motor in short term. Alright, so this looks alright. So this part might work alright when we put the motor together. Don't know. Not until you put the motor together, you don't know. Okay, now over here, we look at our breather hole. And this one looks pretty good. It's got a little grit in there, so you clean the grit out. It's hard to check clearances when you got gritty in there. We also have that cam bushing right there. We got to check that one also. And we got oil pump shaft to check too, which is over here. Run your shaft in there. Pull out about halfway. Here. You go this way and up and down. Feels alright to me. A little clearance in there is not going to hurt us in there. There's not a lot in there, there's a little bit. A couple thou probably, it's fine. Alright, I'm good with that. Okay, here's our cam again. I'm going to check this hole here. Put your finger in there if you can't see very well and just run your finger through it. Easy if it's pretty wavy and crappy, you can feel it really nice, real quick. This one here feels alright. Looks alright. Look in different areas. You get up in there and look in there the best you can. Come up on the top. Do what you can line of sight, trying to see. Overall looks alright. It's got a big groove across the top for oiling, which is cut off here, and then one across the whole face is a groove. Stick it in there. Drop it in there. For some reason we're hitting the case right there. Probably because we don't have a thrust washer on there. It does not appear that there's one in here either. Probably still on the old cam. I'm going to steal the one over here. Okay, I'll put that in there. That. 50 thou is your normal stock starting point for that. So we are hitting on the case. So why is this hitting? We are having a clearance issue. So maybe the S cam is not a stock cam because we are having a heavy clearance issue. Let's see, what's this one? I know this one's stock. Looks like another S cam. Looking at the profile shape to see if there's any difference. Yeah, it looks the same. This one hits too. Alright, well, it's hitting only by about 15 thou, but you know 15 thou is 15 thou. So you got two options. Grind the case away, or grind the lobe here, around top corner. Put a little chamfer right there. It needs almost nothing to clear. So, if you grind the cam for clearance, then whenever you change the cam, you'll have to do it again. If you grind the case away, you'll never have to do it again. So, which option is the best out of doing that? Permanent solution, or every time you work on a solution? You know which one I want to do. Okay, this one here, we're going to check our clearances again. So here's our up and down. And then we go on side to side, front to rear. It's this way. Definitely a lot looser that way than it is that way. That's not uncommon. But that's all within spec of being Harley looseness. So we're alright. But we will have to do something about that clearance issue there. Looks like the cam only goes in there about 20 thou. So basically just put a little chamfer across that corner and that'll be enough to do what we need to do. But that will have to be done. Without a doubt. Have to do that. Okay, next thing is circuit breaker gear and idler gear. And 2 sets of crappy shafts. And a breather valve. So this one here, feel with your thumb how much wear is in there. It's definitely noticeable, but not real super deep. It's there, but not real deep. Stick in the case. Obviously it should drop all the way down, not fighting it like it is right now. So there are some high spots in there someplace. And you check your clearances on here. So it's fairly snug. And obviously it gets tight right there. So probably what I'll do is I'll throw a little paper across the outside of this and see if there's any burrs in that. There might be some grit down inside of this that I don't know about yet from all the sanding on the case, which is probably what's going on because it's starting to go in deeper now. Yes, there we go. It's starting to get looser. There we go. So I didn't clean these cases yet, so they're dirty. There you go. Now it's good to go. These early ones have a fixed shim on the outside. Let's see, what year they changed that? 50, I think. 1950. They put a titty right here, and they had a washer in there. It'll allow you to set the end plate for this, so if it was really loose, you could fix it. If it was too tight, you'd have to grind this off. You just change the washer in the later one. Alright, so that looks like it's usable. Okay, these here go here. And the circuit breaker one goes over here, like this. But it's supposed to be shafts in there. And these are the shafts. You got a short one and a long one. Why would you have a short and a long? What do you think? So this has some kind of a mark in there rubbing, so does this one. So I'm assuming that's probably the retaining clip was eating away on that a little bit. Okay, this one here looks like a new one that's just been getting rusty. This one here is a used one that's definitely rusty. Big rust right there. You can see the wear mark over here where it's used. So that's the used one. This one here, same deal. You can see the used mark, see all gouged up marks. That's the used one. And this one here, I don't see any marks on it, but I do see a lot of rust. So normally when you have rusty parts, I don't use them, but in this case here, just a low RPM thing goes on here. It's on a bushing, which tolerates a lot of lows and highs, with, well, not highs, but lows without really bothering it. So I'll have to take these and polish them down, or put them on an external hone on them most likely. Make sure they're nice and smooth and straight, and then put them together. So initially that went in there fairly tight on that bushing, which is good. Bushing seems to be pretty tight, so I think I'll be good with that. So I don't mind a little clearance, I just don't want a ton. Looking that's okay. This is the other one. That one on the other hand is a little loose. That's a lot looser. That's just the idler, so it's not super critical. It's definitely loose. So this one's loose over here too, and you only got one little small one in there. This is definitely a little bit looser. So this one's probably alright, it's loose. But I'm thinking this whole motor's going to be a little loose, so we're not too bad. Yeah, some dirt up in there I missed. Alright, so these are going to have to be cleaned up. They look new, so they should be alright. I'll go ahead and put them in. So they're held in with a screw, and they're supposed to be a press fit on in the case. Appears to be a tight fit, which is good. When they're loose, it's bad. So that looks good. And what do we got for hardware? There's the factory idler one. They're a flat-headed straight slot screw stock. If you don't have these, you can use an Allen screw, Allen bolt, whatever. Be just fine. On this one, it's 1/4 thread, so it works. And you can see it's deep enough, an Allen will go in there. So that one you don't have a big issue with. This one on the other hand, that doesn't always work. There's the screw for that. So they make these in left and right-handed thread. This one looks like it's a standard thread. See how the pitch angle's going like this? That would be standard. If it went the other way, it would be reverse. So, put in the case and see if it screws in. There's your 1/4 thread. This is not happy about going in that hole at all. So is that because it's full of grit, or is it the wrong thread? Either way, I do not want to force that in that hole. And I think the other motor, the shafts are still in it. Yeah. So I have to go find out if the left-handed thread is early or late. Because I don't remember. All I know is this one does not want to go in this hole. Let's see if it fits in this hole. Okay, it does screw into this hole, a little tight, but it goes in, so I know it's not the screw is the problem. So either the hole's got something wrong with it, or it's supposed to be a left-handed thread, and that's the problem. Hear that grit in there? I think it's full of grit. If it was left-handed thread, it wouldn't start at all. It's actually going in about half a turn. So I think there's a ton of grit in that hole. It's keeping it from going in. So I'm not going to force it in there because I'll screw the hole up. So these cases need to be cleaned up really good. So it's probably the correct bolt. So knucklehead must use early standard thread, and panheads must have the reverse thread one, left-handed thread on it. So I know they changed. Just not sure what year they were. Don't remember. All right, so we got more stuff to clean up there. These will work. Look for wear on this. If this is nice and straight all the way across the teeth, which means it's the same width all the way across, it's good. When it gets hourglass shape, real thin right in the middle, it's worn out. So it looks good. That's for all worm gears. So you can see how the wear on these, see how they're all not sharp edge right there on the edge. That's wear. But it doesn't look like it's bad enough to replace, but it is worn. Now this should be a 5 tooth. 1, 2, 3, 4, 5. See, you count the teeth this way, not this way. You can see each one right here. 1, 2, 3, 4, 5. So this should be a 25 tooth, and it looks like a 24 tooth. So my guess is it's got the wrong gear on the damn thing. Yeah, where's our buddy's parts over here? And that looks like the same small gear. It is. So, I have to count these to see if they're 25 or these are 24. I lost track already. You could mark it, but it'd be too easy. Plus my fat finger is a problem. I use a skinny finger. $25. Okay, it's the correct tooth. 24 is the small one, which is used on later bikes, aluminum oil pumps, starting in 75, I think. That's how they sped the oil pump up. They went 6 tooth here, 24 there, 5 tooth here, 25 there. That's how it works. When this goes smaller, that one goes bigger. When that goes smaller, this one goes bigger. 1 tooth difference is the difference. Okay, this is the seal that goes right here on top of the bearings setup when we put it in. Okay, so I gotta find me a case race. See what we're gonna do about some other parts and pieces, and we'll go from there. All right, that's it for this one for right now.